Question 14d. The shaded region shown is enclosed by two parabolas, each with x-intercepts at x equals -1 and x equals 1. The parabolas have equations y equals 2k times x squared minus 1 and y equals k times 1 minus x squared, where k is greater than 0. Given that the area of the shaded region is 8, find the value of k. The following are the marking guidelines for question 14d. For 1 mark, we have attempts to use integration to find the area of the shaded region, or equivalent merit. For 2 marks, we have obtained an expression for the area involving k with integration complete, or equivalent merit. And for 3 marks, we have provides correct solution. It is given that the area between the two parabolas is equal to 8. Hence, we can form the equation 8 equals the integral from x equals -1 to 1 of k times 1 minus x squared minus 2k times x squared minus 1 dx. Now, k times 1 minus x squared is the upper curve, or the concave down parabola, and 2k times x squared minus 1 is the lower curve, or the concave up parabola. Now, note that the integrand is an even function, so rather than integrating from -1 to 1, we can integrate from 0 to 1 and halve the area. Also, we can factorize out the k. So the equation becomes 4 equals k times the integral from x equals 0 to x equals 1 of 1 minus x squared minus 2 times x squared minus 1 dx. Expanding the brackets, we have 4 equals k times the integral from x equals 0 to 1 of 1 minus x squared minus 2x squared plus 2, because we have -2 times -1, which gives us +2 dx. Combining the like terms, we have 4 equals k times the integral from x equals 0 to 1 of 3 minus 3x squared dx. Now we can divide both sides of this equation by 3. So we have 4 over 3 is equal to k times the integral from x equals 0 to 1 of 1 minus x squared dx. And integrating this function, we get 4 over 3 is equal to k times x minus x cubed over 3 from x equals 0 to x equals 1. Applying the limits of integration, we have 4 over 3 is equal to k times 1 minus 1 over 3. And 1 minus 1 over 3 is equal to 2/3. So we have 4 over 3 is equal to k times 2 over 3. And solving this equation, we have k equals 2. The following is the feedback from the Marking Centre for question 14d. Common problems were making algebraic errors when subtracting the functions, finding an incorrect primitive, and substituting into k instead of x in the primitive function when evaluating the limits.